All right, now we're going to talk about geometric series. We just did arithmetic series, which was where we add up all the terms of an arithmetic sequence, and now we're going to add up all the terms of a geometric sequence. So a geometric series is the sum of a geometric sequence. So if you remember the geometric sequence, an example was 2, 4, 8, 16. So that was 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and we had r equals 2. R is our common ratio. The geometric series, we're just going to add those up. So 2 plus 4 plus 8 plus 16 plus however many terms there are in the sequence. Geometric series can be either finite or infinite, just like the arithmetic series. And we're going to start out with our formula to find the nth partial sum. So that's going to help us find, like say we want to find the sum of the first 40 or the sum of the first 25, something like that. So n would be 40 or n would be 25. So our formula to find the sum of the nth terms of a geometric series is a sub 1 times 1 minus r, common ratio, to the n over 1 minus r. That might seem complicated, but it's really pretty easy. This is also called finding the nth partial sum. So that's how you'll typically see it. The problem will say, find the nth partial sum, find the 30th partial sum. Right, so here's our first example, find the sum. Now, it looks a little confusing at first, but once we kind of write down what these things are, it's not going to be so bad. First, we want to look at this 4 times 0.3 to the n minus 1. Well, that is in the exact form of our geometric sequence formula. So remember that was a sub n equals a sub 1 times r to the n minus 1. So what you're looking at here, even though you may not realize it, is this 4 is the a sub 1. So that's a sub 1. This 0.3 is the r, and the n minus 1 is n minus 1 from the formula. So when you see one written like this, it's already giving you your a sub 1 is 4, your r is 0.3, and your n, we look right here to go from 1 to 12, n equals 12. So we have all the things we need to use this formula. So we're just going to use the formula. So the sum from 1 to 12, so the sum of the first 12 terms, equals a sub 1 times 1 minus r to the n over 1 minus r. Now we just plug everything in. So s sub 12 equals 4 times 1 minus 0.3 to the 12th divided by 1 minus 0.3. Now, this is all got to go in the calculator correctly or it's not going to work for you. So you want to make sure in the calculator that you get the parentheses on here if you don't subtract this before you put it in the calculator. But punch all that in and you get 5.7. And all that says is that with this geometric sequence that starts at 4 and does 4 times 0.3 and then times 0.3 times 0.3 times 0.3, at the end when you add up the first 12, it equals 5.7. And that should make sense to you because your A1 is 4, your A2 is 4 times 0.3, which is 1.2. And then we times 3 again, or times 0.3, sorry, and we get 0.36. And if we keep doing that times 0.3, all the way down 12 times, you can see that we're getting smaller and smaller and smaller numbers added together. So to go from 4 to 5.7, that's not unreasonable. That's what those 12 numbers added together would be. So just keep in mind that's what's happening here. All right, next one, find the 24th partial sum. Okay, and we have a series written out here. It says the sum from 1 to infinity of 2 times 3 over 2 to the n minus 1. Well, remember, this is our n, right? And our a sub 1 is 2 because our formula up here, remember a sub 1, this is a sub 1 times r to the n minus 1. So our r is 3 over 2, and our formula that we need to use to find the partial sum says that s sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Well, we know a sub 1, we know r, and we know n. So the sum of the first 24 terms of this series, 2 times 1 minus 3 over 2 to the 24th over 1 minus 3 over 2. Again, all that can go in the calculator, straight in the calculator, as long as you get your parentheses right. Maybe safe and put some around the fractions too, so you don't ever mess any of that up. And you should come up with S sub 24 equals 67,332.4. And that's a whole lot easier than punching this out 24 times and then adding all the pieces together. All right, next example. Find the nth partial sum of the geometric series given a sub 1 equals 3, a sub n equals 768, and r equals negative 2. So remember, here's our formula. We'll write it on this page again. Sn equals a sub 1 times 1 minus r to the n over 1 minus r. Well, a sub 1 equals 3, no problem. R equals negative 2, no problem. N equals, we don't know. So we're going to have to find out what n is. Now, just like with the arithmetic sequence, we can go back to the, just like with the arithmetic series, we can go back to the formula for a geometric sequence, which is a sub n equals a sub 1 times r to the n minus 1. And we know all of these things except for n. So a sub n is 768. A sub 1, the first term, is 3. R is negative 2 to the n minus 1. Okay, so we need to be mindful of our operations rules and how we solve equations. This says 3 times all of this. So the first thing we need to do is divide both sides by 3. So 768 divided by 3 is 256. So that equals negative 2 to the n minus 1, which looks a little odd, right? But if you think back to our exponent rules and how we work with exponents, 256 is 2 to the something, right? Now we have a negative 2 here, so we're going to see if we can do negative 2 to the something. And you just take your calculator and check real quick. 256 is negative 2 to the 8th. And that equals negative 2 to the n minus 1. So, real conveniently, 8 equals n minus 1. So n equals 9. Now we know our n, we know our a1, we know our r. So we can use our formula to find the sum. S sub n equals a1 times 1 minus r to the n over 1 minus r. Remember, our n is 9. So S sub 9 equals 3 times 1 minus negative 2 to the 9th. Remember, this is negative 2 to the 9th divided by 1 minus negative 2. So it's very important that you get your negatives and your exponents and your parentheses. So again, put all that in your calculator, nice and careful, parentheses, everything right. Make sure that this is a minus sign here, negative sign here when you're typing on your calculator, and you should get that S sub 9 equals 513. And so what that means is that the first 9 terms of this series that goes 3 times negative 2 times negative 2 times negative 2, the first 9 terms of that series ends at 768, and if you add all the terms together, it equals 513. And that should make sense because the first term is going to be 3, but the next one's going to be -6. So if you start adding them together, every other term is negative. So that's no problem that that answer is less than 768. All right, number 4 says use sigma notation to write the sum. That means when you see this, use sigma notation, that means you need to make one of these. Okay? So to make one of these, we want to know, go from n equals 1 to k, which we don't know how far it is, of a sub 1 times r to the n minus 1. Okay, so we have this sequence right here. And we know that this is A1, A2, A3, and this is A n, right? Now, we know our formula says that a sub n equals a sub 1 times r to the n minus 1. Right, that's our formula for our geometric sequence. So a sub n is 896, a sub 1 is 7. Now, r, we know 7 times 2, 14 times 2, 28 times 2, so r is 2 to the n minus 1. So just like the problem we did before, we're going to divide both sides by 7. 896 divided by 7 is 128 equals 2 to the n minus 1. And now very conveniently, 128, you can check with your calculator, is 2 to the 7th. So 2 to the n minus 1. Now the 2's, just don't worry about those anymore. 7 equals n minus 1 plus 1 plus 1. So 8 is our n. So our summation says we're going to go from n equals 1 to 8. And I put k up here. That just was a different letter than n, so I didn't want you to get confused. K's and n's are kind of interchangeable on these. Of a sub 1 times r to the n minus 1. So that is the way you would write 7 plus 14 plus 28 plus all the way up to 896 without actually writing it all the way out. All right, last one. Use sigma notation to write the sum. So here we have our series, and we know that a sub 1 is 729. We know that a sub n equals -3. And we know that r equals, we have to figure it out. So if we can't recognize it immediately, we do a sub 2 divided by a sub 1. Then we do a sub 3 divided by a sub 2. And as long as they're the same, which they come out to -1/3 and -1/3, that's how we know it's a geometric sequence, and that's our r, our common ratio. So we know a1, we know a sub n, we know r, we just don't know how many terms there are. So a sub n equals a sub 1 times r to the n minus 1. So -3 equals 729 times -1/3 to the n minus 1. So first thing we want to do, divide both sides by 729. So we get -1 over 243 when we simplify that equals -1/3 to the n minus 1. Now, probably thinking that doesn't look like the ones we just did. Well, it really is the exact same thing because -1 over 243 is -1 over 3 to the 5th power, because -1 to the 5th is -1, and 3 to the 5th is 243. So this is where all that exponent and log stuff is going to really come in handy. -1 over 3 to the n minus 1. So 5 equals n minus 1, so n equals 6. And then we can write our summation. So this is the sum from n equals 1 to 6 of a sub 1, 729, times r to the n minus 1. And all that says is we're take 729 is what we start with, and we're going to multiply it by negative 1/3, however many times it takes to get to the end. So that is it. Hopefully it wasn't too long. See you tomorrow.